The second process is called upset forging. We have three major facilities to perform upset forging: 160-ton, 300-ton, and 400-ton press. This is an example of upset forging. Before upsetting and after upsetting. At first, let's see, why do we perform upset forging rather than directly doing the forging process? Purpose of upset forging. Metal rods are often produced in standard sizes that may not match the exact requirements. For instance, if you need a metal rod of a specific diameter that is not readily available in the market, ordering a custom size can be expensive due to additional manufacturing costs. Upset forging is employed to alter the dimensions of existing metal rods to match desired specifications without the need for costly custom orders. Secondly, why is upsetting important? Number 1, cost reduction. By using upset forging, manufacturers can work with readily available metal rods of larger diameters and modify them to meet their specific needs. This avoids the need to order custom-sized rods, which can be more expensive due to additional setup and tooling costs. Number 2, enhanced strength. The process of upset forging involves changing the grain structure and metal flow within the rod. This alteration in material structure results in improved mechanical properties, making the metal stronger and more durable. Number 3, waste reduction. Upset forging reduces scrap generation because the process involves pressing and reshaping the metal without generating excess waste. This efficiency is beneficial for both cost and environmental reasons. Here you can see upsetting is performed without using dies. In cases where the workpiece is too long during the upsetting process, the possibility of bending arises. To prevent bending, dies are employed. In summary, upset forging is a valuable manufacturing technique that enables the alteration of metal rod dimensions and properties to meet specific requirements. It offers benefits such as cost reduction, improved material strength, and waste reduction, making it a preferred method for achieving precise and cost-effective metal components. This was the second process of production. The third process is annealing. See you in the third video.